Okay, we're going to look at more of these piecewise functions here today. We looked at absolute value yesterday, which is really a piecewise function where it's dependent on some conditions. So for this one, you can see it's a piecewise function. There's two functions here. This one, 1 minus x, and this x squared one. So really what this means is we got y equals 1 minus x as one of our functions, and y equals x squared as one of our functions. The conditions that we are using for those are listed after the function. So you want to look after the if and see when is this function going to be on our graph. So the first one is when x is less than or equal to 1. The second one is when it's greater than 1. So one idea when you're doing these, if they ask you to graph it, would be to find that point where it's changing. Looks like 1 on this in this case, where x equals 1, and just kind of make a light dotted line on your graph to kind of help you remember that's where it should be changing. Okay, now you want to graph these two out. So the line 1 minus x, that's a pretty easy line to graph. You guys have seen that before. That's just slope-intercept form. If we were to switch those two around, it would be y equals negative x plus 1. So that's one with a y-intercept of 1. Slope is negative 1, so down 1 over 1, or up, sorry, down 1, right 1, or up 1, left 1, and it would just continue. Okay, so if it was just that by itself, it looks something like that. Okay, but we got a condition on here. It's only that line when we're less than or equal to 1. So any x value greater than 1, or to the right of 1, we don't want this line. So this part of the line, you don't want. It's going to stop when it hits 1. It'll keep going this other direction, so we can put an arrow on there, but it should stop when we hit 1. Okay, the next part of the line, y equals x squared. You've also seen this one before. This one's a parabola. And we can easily get some points for this just by plugging in. Like if you put 0 into that function, 0 squared is 0. 1 squared is going to be 1. 2 squared is going to be 4, so 2 4 is a point. And we can connect those and get part of the line here. Same with like negative 1 squared would be 1. We know it's symmetrical, there's going to be a point there. But again, we don't want this on both parts, both sides of this line. This is only going to be part of the graph if it's greater than 1. Okay, so we want only to the right of this dotted black line that we had drawn it. So only over here should we get this. All these other points we had made are to the left. We want to erase those and not have those be a part of our graph. All right, the last thing now, if we look at this, right now this one is not a function because at this line x equals 1, where we had drawn this black dotted line, we have 2 points right now, this one and this one. If there's 2 points there, that means it's not a function. It doesn't pass our vertical line test. So we want to look and see where should we have a closed circle and where should we have an open circle. And you can tell that by looking at the conditions here. On the first one, it has a less than or equal to 1. So our red line is where it should be equal to. This is the one we should have a filled in one. The second one condition doesn't have a or equals to. That means our point doesn't exist right at 1. So on our blue line here, this should be an open circle at 1. Now this is a function, and we have graphed out exactly what the graph is telling us to. Okay, the second part wants to know what's the domain and range. We talked about domain and range yesterday. Domain is x, range is y. Okay, so what are x values here for the domain? Well, as you can see from the graph, the red line is going to take care of every x value from 1 to negative infinity. And the blue one actually starts right where the red one left off at the value of 1 here. And that one's going to keep going to the right forever. So the domain for this is actually all real numbers. We can put any number in this function and get one out, get a value out. The range is our y values. What y values do we got? Well, you can see from the graph here, this graph never goes below the x-axis. The lowest point is located right there. Okay, so we know it never drops below that. But it looks like every value above that we can have, because both sides of this graph keep increasing. So then our range would be 0 to infinity. Infinity is not a number, so we know parentheses on that side. Does it include 0? Yeah, right at that bottom red dot, it does include 0, so we'd want to bracket that in. Okay, so piecewise functions that are based off of conditions, they still have domain and ranges. Let's look at even and odd functions. This is something that may come up now and then throughout the year. A function that is even is where f at the opposite value is equal to f of x for every x in the domain. By saying this, we are saying it's always going to be symmetrical about the y-axis. This picture here shows an example of a even function. You can see this red one is symmetrical about the y-axis. There's a point on each side here that is identical to the point over here. Okay, a function is odd if the function at the opposite value equals the negative value of that function for everything in the domain. Another way of saying that is it's going to be symmetrical about the origin. So if you look at this next example, okay, if you have a value here and a value here, okay, it's symmetrical about the origin. It's the same distance away on either side. And that's true for every point here. There's a symmetrical value opposite the origin. Difference quotient. This is used frequently in calculus to represent the average rate of change. We're going to be working with this more in chapter 2, but it's kind of going to be introduced here just as something that you should be able to kind of simplify if numbers are put in there. So for this first one, they want to know if f of x equals this function shown, evaluate the difference quotient. All right, so what we want to do is put in this function into the difference quotient here and evaluate it. So what you're going to do first is figure out what would this be at f of a. Okay, f of a, meaning what would you get if you put a in for the function? Well, basically it would just be replacing all these x's with an a. So we get 2a squared minus 5a plus 1. Okay. We also, besides f of a, have another function here, f of a plus h. What's that going to give us? Okay, well, this one's a little bit harder. This means everywhere we have an x, we're going to replace it with a plus h. And let's simplify that a little bit. Here, this is an easy simplifying. All we got to do is distribute. Negative 5a. Now we're distributing a negative 5. Okay, so it'd be negative 5a minus 5h plus 1. On the left side here, this one's a little bit harder to simplify. We got 2 times a plus h squared. Remember, if you're squaring something, that means you got 2 of them. We're multiplying a plus h. times another a plus h there. So we're going to have to go through and FOIL that out to see what that's going to be. So if we do that, a times a is a squared, a times h, and there'll be another a times h, so there'll be two a times h's, and then h times h is going to be h squared. Okay, now we want to go through and multiply all those by 2. So it'd be 2a squared plus 4ah plus 2h squared minus 5a minus 5h plus 1. We should probably look quick and see if there's any like terms, but I don't think there are any like terms there. Okay, so now let's put all this in the difference quotient. Okay, so we're going to take what we got here for f of a plus h, substitute it there. We're going to take what we got for f of a, substitute it there, and then try to evaluate this. So doing that, we got this. Okay, so simplifying that. Notice here that we have a negative, or subtracting all this function here, so all these need to get simplified, almost like we're distributing a negative sign there. So let's change the sign on all those. So this will turn into plus 5a because it's minus a negative, and then minus 1. All right, all over h. Now we want to look, is there anything we can do to simplify? Well, yep. We got a negative 5a and a positive 5a. Those are opposite terms. They'll cancel out. 2a squared minus a squared. Those two are going to cancel out. Plus 1 minus 1. Those are going to cancel out. So what we're left with here is 4ah minus 5h all over h. Okay, can we simplify that anymore? Well, yeah, this h on the bottom, and then it looks like both terms on top have an h. We could do some factoring in order to cancel that out. So anytime two terms have something in common, we know we can factor. So if we factor an h out of the top, that would be 4a minus 5 left over, all over h. Now, since this is being multiplied, we can cancel out the h. And so the final answer here would be 4a minus 5. What we're going to learn later in Unit 2 is that 4a minus 5 has some important significance when dealing with calculus. All right, why don't you guys pause the video, try this one out. This is another difference quotient here, and see if you can evaluate this one, and then check your answer by playing the video. All right, let's see what you got. First one, the two things we need to find here is f of 2. Okay, so what do you get? You put 2 in here. Well, if we put 2 in here, you would get 2 to the third is 8, plus 1 is 9. Okay, so that's one we had to find. The other one is what is f at 2 plus h. So if you put 2 plus h into this function, replace the x with 2 plus h, we get that. And this one's much harder to evaluate here. 2 plus h cubed means we have 3 terms of 2 plus h being multiplied. So we got to do 2 plus h times another 2 plus h times another 2 plus h. And we still got that 2 plus 1. So you're just going to have to pick 2 of these to multiply here first. Let's just do the first 2 here. So if you FOIL that out, it's going to be 4 plus 2h plus another 2h, so plus 4h plus h squared. Okay, but you're still going to have to go through and multiply this next one out. So everything here has to get multiplied. So start by multiplying everything times everything else. So 2 times 4 is going to be 8. If we multiply the 4 to the second term, you're going to get 4h. Now I'll go to the next term, 4h, and multiply those to both of the other ones. So plus 8h plus 4h squared. And finally multiply h squared to both of them. So plus 2h squared plus h squared times h is h cubed. And then we still got that plus 1 term. Okay, now we want to go through, combine any like terms. So 8 plus 1 is going to be 9. We got these two are like terms, plus 12h. These two are like terms, plus 6h squared, plus h cubed. Okay, now we've kind of simplified that as much as we can. So now hopefully you plug those both into the difference quotient. So we're going to put 9 here. We're going to put what we got right here in there and then evaluate this one. Okay, so let's do that. So putting those into the difference quotient, you're going to have this one minus 9 all over h. What does that simplify to? Well, we know 9 minus 9, that's going to cancel out and equal 0. So we have 12h plus 6h squared plus h to the third all over h. All those terms on top have an h. Factor it out. And then we can cancel these h's. And so the difference quotient answer on this one would be 12 plus 6h plus h. Okay, and that would be the solution to that one. Okay, I want you to continue then working on what you started yesterday with this book assignment. Try these problems out. We said do Thursday on this, and then if you get some questions, we can look at them tomorrow in class.